everybody. I'm Anusha, working as Assistant Professor in Computer Science and Engineering Department in the Institute of Aeronautical Engineering. In today's video, we will be discussing about the question bank of Unit 2, which is a continuation of the previous video. So let's move on to the first question. It is to compare and contrast overloading and overriding methods. So overloading and overriding methods are two forms of polymorphism, wherein method overloading is compile time polymorphism which occur during compiling, whereas the method overriding it occurs during runtime. So it is also called as runtime polymorphism. This method overloading is used to increase the readability of the program. So what happens in method overloading is we'll have a class A. Let's say we are having a class A with method, say, PQR. Okay. So there will be different forms of the method PQR. Okay. So this method overloading will happen within a class. So there can be more than one PQR methods which of different forms. So let's say this is one form. PQR of taking an integer and PQR taking two, let's say one character and a double. So these are different forms of same method PQR. So PQR method is existing in different ways in the same class. So how will we differentiate among these three? That is, in method overloading, the methods will be having the same name, but the signature of the methods, that is the parameters passed to it, will be different. It may either take no parameters, or it may have one parameter or two parameter or any number of parameters of different types. Okay, so there is the existence of the same method in different form is called as method overloading, which happens during and this happens during compile time itself. So it enables it increases the readability of the program. It is performed within the class, that is, the different methods are present within the class. It has the method name will be the same, but the signature of the methods will be different. It is an example of compile time polymorphism, and method overloading cannot be performed by changing the return type of the method only. Return type can be the same or different in method overloading, but the parameters passed to it will be different. So depending on the parameters passed to that method, the compiler will understand which method to invoke during compile time. Now when we look into method overriding, it happens in inheritance, like wherein we will have a parent class with one method. The parent class will be there with, say, method PQR with some parameters passed to it, and another class B extends this class A. That means B is inherited from class A, and B will also have its own form of method PQR. So here the name and the parameters passed will be the same in case of method overriding. So it happens in inheritance. So the child class will be overriding the method which is present in the parent class. So here the method overriding is used to provide the specific implementation of the method that is already provided by its superclass. It occurs in two classes, that is a inheritance relationship. In case of method overriding, the parameters passed to it, that is the signature of the methods, will be the same. And it is an example of a runtime polymorphism. The return type must be the same or covariant in method overriding. Next question. Discuss the importance of final keyword with a program. So, by using we can use final keyword at three places. We can use final keyword on a variable, or on a method, or on a class. So if we apply final keyword on a variable, it is defining that as a constant. That variable will be always made as a constant if we apply final keyword on a constant. So when we define any keyword, variable as a final, then we have to declare it in advance, and this it can be declared it can be given the value when it is declared, or it can be assigned a value in a constructor. And generally, all the when we are declaring any variable as a constant, then all it will be named in uppercase. For example, we are defining an int variable named as file new as integer with value 1. So this is a final value. A constant value. So wherever this file new variable is used in our program, there and all, it will be using the value 1 as 1. So it cannot be modified in the program. When you declare any variables as final, they cannot be modified within the program. So we can have both parameters and local variables which can be defined as final. And next we can have final applied on methods. So when you define any method as final, then those methods cannot be overridden. It cannot be changed by the child class. So let's say we are having a class A with a method named meth, which is defined as final. So now we are having a class B which is inheriting the class A. So B class can have it will inherit all the members of the class A. That means it will inherit the method meth also. But the meth cannot be overridden. That means meth cannot be changed. Its implementation cannot be changed by the child class B. So when we define any method as final, by keeping the final keyword in front of it, we are preventing the overriding of that particular method by the child class. Now we can also use final keyword over an class. So when we define a class as final, then that class cannot be inherited. So if we give that final keyword before that class, then it declares all the methods and all the methods of that particular class as final. That means you cannot extend that, or inheritance is prohibited when you define any class as final. And when you and it is not good to have a class declared both abstract and final. So if we have a class named A which is defined as final, then when we try to implement when we try to extend that class by a child class B, then this will throw an error since it is not allowed. So these are the three uses of final keyword. So if you apply final keyword on a variable, it creates constant variable. If we define final over methods, then it prevents method overriding. And when we make classes as final, then it prevents inheritance. Next question is to discuss in detail creating and importing package in Java. So packages are mainly used to provide naming and visibility control mechanism. That means we put the classes of the same type in one particular package. Like for example, if you consider math class, all the methods related to mathematical operations, we place it inside the math class. So it is providing a mechanism for partitioning the class namespace into more manageable chunks. So using packages, it provides both naming and visibility mechanism, and it also prevents naming conflict. That is, a same package cannot have two classes with the same name. And to control access by that is, if you have some variables defined inside one package, and a method from an outer package may not be able to access all the variables inside that particular package. By specifying the access specifiers, we can limit the access of members of one particular class or package by another. Then it makes the searching and locating of the classes easier, and classes, interfaces and enumerations easier. So we can define classes inside a package that are not accessible by code outside that package. So by specifying any access specifier like private, public, default or protected, we can manage the accessibility of any particular member outside that particular class. So we can define the class members that are exposed to only other members of the same package, and also it also provides a mechanism for grouping similar type of classes. Now, if you want to define a package, we make use of the statement package, keyword package. So when we the first statement of any Java program will be specifying the package in which it exists. So when we specify the let's say we are having a statement like this as the first package. So here pkg is the name of a package in our course in our source file. So what it understands is that the code which follows it is placed inside the package named as pkg. Now also we can create a hierarchy of packages by using the dot operator. So if you consider this package, we says that we are making use of the image class of the Java's AWT package. Now let's see a small example of using a package. So we are having a package name package, a package one created inside our source inside our JDK. So when we after creating and when we want to store any class inside that, we have to we have to make this statement as the first statement of our program. This indicates that the following class, this class A, is placed inside the package 1. Now we are having another package, another class named as test package, which is trying to access the members of class A. So what happens here? Now since this package test package wants to access the member of class A, then this class A must be imported into the test package. So to import that particular package, we make use of the import statement. This line indicates that we are accessing class A of the package 1. So this whole class will be brought into this particular method, into this particular class. So now here inside this class named as test package, we are creating an object of that class and accessing the display method of that particular class A. So this display method is printing this statement. So in the output, we get the particular statement. So this to import the packages, we make use of the import statement. Now this import statement again, it specifies that here let's say we are having this statement. So it imports the particular date class from the util package of the Java package. Java's util package, from the Java's util package, it is importing the date package. And now in this case, if you provide star, then it imports all the packages from the IO package of Java. Sorry, all the classes of IO package of Java. Next question. Examine the different ways to extend interface with an example. We can extend the interface by making use of the extend keyword. So one interface can inherit another interface by the extends keyword. So it is same way as how we use it on our classes. And when a class implements an interface that inherits another interface, it must provide all the implementation for all the method required by the interface inheritance chain. Let's see an example. So in this case, we are having an interface A with two abstract methods, meth1 and meth2. Then we are having an interface B, which is extending that interface A. So, and B is having its own abstract method, methb. Now, my class is a class which is implementing interface B. So, this since B is extended or inherited interface A, this class has to provide an implementation for all the three methods, meth1, meth2 and meth3. So, here meth1 is given some implementation to print something. Meth2 and meth3 is also given some implementation. Then the driver class is creating an object of this my class and it is invoking the meth1, meth2 and meth3 methods. So which will in turn print these three statements onto the console. So the interface can be extended by using the extends keyword, as same as in as same. It is the same way in by same as inheritance of classes. So a class can extend another class. That means a class can inherit a class, and a class can implement an interface, and an interface can inherit a interface, another interface. So there can be a parent and child interface. Next question. Describe the importance of interfaces by using an example. So interface is mainly used to provide abstraction. Two things are achieved by to provide abstraction and to implement multiple inheritance. Now, if we are going for abstraction again can be achieved by using abstract classes or interfaces. When we use abstract classes, the interfaces, when we use abstract classes, it will provide only partial abstraction, but interfaces provide complete abstraction. That means all the methods in an interface are always abstract. That means they don't have any implementation for those methods, and these interfaces are very much similar to classes, but they lack instance variables and their methods are declared without any body. The interface variables are always static, and they when the methods of the interfaces being abstract methods, the classes which is inheriting or the classes which is implementing that particular interface has to provide the implementation or the body for the for that particular method. And also, since Java does not permit multiple inheritance using classes, they brought up this multiple this interfaces to achieve multiple inheritance. Now, since the problem while using the problem in using classes in interfaces, classes as classes for multiple inheritances, because of the ambiguity created during this ambiguity created by the diamond problem. That means let's have two classes, class 1 and class 2. This is class 1, this is class 2, which is having the same method with the same name, say print. These both classes are having print method, and this is having one implementation and this is having another implementation. Now let's say we are having another class which is inheriting this class 3 these two classes. So what happens? This class 3 will get both the copies of print method, and when an object of class 3 is invoking the print method, there will be an ambiguity of inheriting ambiguity of using which one of these. So this, to prevent this ambiguity, they have created the interfaces wherein these two interfaces won't have, even though they have the same method print, there won't be any implementation for this method. So the class which is implementing that interface, so here this print is this class 3 is implementing both class interface 1 and interface 2, then this print method will be given the body or the implementation inside this class 3. So there won't be any ambiguity. And this also supports dynamic method resolution at runtime. An interface cannot contain a constructor to create object. Now this is the general form of an interface. We'll specify the access specifier keyword, the interface keyword and its name. Then these are the interface variables. Now these variables are always public, final and static. And that means it should be assigned a value at the time of creation, and it cannot be, it must be always initialized, and they cannot be changed since they are final. And you can have more than one abstract methods also inside the interface. The methods are always public and abstract, and there are some methods called as default methods and static methods in interface, which allows to provide the body for that body for that interface. Now this is an example of creating an interface. So here we are creating an interface named as callback, and there is a method named as callback, which is an abstract method. So this is the basic syntax. We specify the class name. If their class is extending any other superclass, then it comes first. Then it implements the interface. It can implement more than one interface. Now this client, there is a class named as client, which is implementing the callback. So since this callback method is an abstract method, this client has to provide the body or the implementation of that particular method, callback. Next question is to differentiate between classes and interfaces in Java. Now, class is a keyword used to create a class, whereas interface is the keyword which is used to create an interface. An object for a class can be created. The classes doesn't support multiple inheritance. Classes can be inherited by another class using the keywords extend. It can contain constructors, and classes cannot contain abstract methods, and variables and methods can be declared using any specifier like public, protected, default or private. Whereas in interface, the interface keyword is used to create an interface. An object of an interface cannot be created. It supports multiple inheritance. An interface cannot inherit a class. An interface can be inherited by a class using the keyword implements, and it can be inherited by another interface using keyword extends. An interface cannot contain constructor. It consists of abstract methods only, and variables and methods are declared as public only. So these are the various differences between class and interface. Next, describe the importance of inheritance in an object-oriented programming language. The inheritance is the property by which one class achieves the features of another class. So here we have a class named A, and class B is inheriting class A. So class B will achieve all the properties. It can be variables or methods of this particular class. So class B will have all the members of class A, and class B can have its own properties also. So the class A, this class is called as a superclass or the base class or the parent class, and the child class is called as a subclass or the derived class. So the subclass is a specialized version of the superclass, and it permits the sharing and accessing properties of one class to another. Now this inheritance relation is achieved using the extends keyword, and the main important feature is that it supports reusability. That means it supports the concept of reusability. That is, the new class, the subclass, the child class is reusing the fields and methods of the existing superclass. And these are the few benefits of inheritance. The first one is reusability, wherein it facilitates the use of public methods of base class without rewriting the same. Extensibility, extending the base class logic as per the business logic of the derived class. Data hiding, the base class can decide to keep some data private so that it cannot be altered by the derived class. Overriding, with inheritance, we will be able to override the methods of the base class so that meaningful implementation of the base class can be designed in the derived class. So that's all for today's video, and in this video I have discussed about the I have to prepare this video. I have used Herbert Shield, the complete reference, Java complete reference, 9th edition, and I had used Java T-Point website and Oracle tutorial website to prepare these slides. Thanks for watching my video.
Like, share and subscribe. Hit the bell icon for more updates.